Alright, geometry, I think I'm just going to go ahead and do this thing. I might actually get to the whole thing, we'll see. I'll start at the beginning, see how far I get, see who's watching, see if they appreciate it, see if I need to make more. Okay, for the beginning, here we have, this is 5, and this thing is 15. This piece in here is the geometric mean of 5 and 15, so you could set that up as proportions. 15 is to x as x is 15. Or you could go straight to the definition sort of a geometric mean and go, oh, I need to take 15 times 5 and take the square root of that. So either way, any way you do it, the next step turns out to be x is the square root of 15. Sorry, not 15, 75. Oh, and if you had the new calculator, check this out. I could just go, oh yeah, the square root of 75 is, oh yeah, it's 5 square root 3. Or you could realize that, yeah, you could take the 25 out of here and get a 5. Or decimalize these and see if you get the same answer. Okay. Which of the following geometry figures cannot be inscribed in a circle? We talked about this in class. The fact that it's rhombus. Look at the other one. Scaling triangle. Any triangle can be put on a circle. Give me any 3 points. I'll make you a circle that goes through those 3. Sketchpad can do that for you. The other one is isosceles trapezoid. Yeah, if you had an isosceles trapezoid, turns out that the 4 points of the corners of the isosceles trapezoid, yes, would fit on a circle. I don't have a really good reason for why that has to be. I'm sure of it. If I did the perpendicular bisectors of all these sides, they'd be the same. They'd intersect in the same point. That'd be the center of the circle. Rhombus. I guess you can just sort of imagine this, that if you had a rhombus, there's no way you could get one circle to go through all 4 of these corners. So that's impossible. Alright, number 3. If 1 is congruent to 2, what else do you need to know in order to prove that ABEF is a parallelogram? Well, if 1 is congruent to 2, then you know BE and AF are parallel because of corresponding angles. There's some stuff here that has to do with angle 3, so let's think about that. If 2 and 3 were congruent, I have AIA. Basically, what I need to be able to prove here is why is that parallel to that? And I need to know that in order to meet the definition of parallelogram. If they told me additionally that AF is parallel to BE, I'd say, well, thank you very much, I already know that. If they told me that 2 is congruent to 3, that would be great, because then I would have AIA angles, and I would know that then, yes, these would be parallel. So that's what I need. AB is parallel to FE. Oh, sorry. It's like, that would be great. Oh, no. It's about congruent. If they're congruent and the other sides are parallel, that's not enough to show it's a parallelogram. It could still be an isosceles trapezoid at that point. 1 and 3 are supplementary. That's not helpful. 1 and 3 being supplementary doesn't really tell me anything at all. Other than 3 and 2 are supplementary, and I really kind of don't want that. I want 3 and 2 to be congruent. Alright, 4. Diagram illustrates congruent circles enclosed in a rectangle. What's the percentage? So I'm going to find the area of this shaded stuff. And I'm going to divide it by the area of the whole rectangle. Shaded divided by entire rectangle will give me the percentage I want. Well, the rectangle I'm going to need anyway, because I'm going to need the rectangle for shaded. So it's really going to be rectangle minus 3 circles divided by rectangle. So the rectangle is very important. So what are the dimensions of this rectangle? Well, this is 18, this is 6. That makes the rectangle 108. And the 3 circles are each, well, if this is 6, then this must be 3. 3 times, this would be 9 pi, which is 27 pi. So in your calculator, you go, I'm just going to start using this now, 108 minus 27 pi. Oh, the pi is in a cool place. I forgot. Where is it? Sorry, I was looking for the pi. Oh, there's a pi in a cool place on this thing. Oh, yeah, it's just right here. Pi. Great. And that doesn't simplify. Divided by 108. Notice how it prints that. You get this. This is negative pi minus 4 over 4, which you can recopy and go, tell me the decimal version of that, please. And it's something like 0.21, which is around 21%, which is B. Okay. No, I didn't expect you to have that calculator, but I'm just kind of giving you a preview to how cool that is. Alright, in the figure, this is a right angle. SQ is congruent to VQ, and the big angle here is congruent to the big angle here. Well, the big angles are not in the triangles they're talking about. The triangles they're talking about are these overlapping guys down here. But I can say that because those 2 big angles are congruent, that the big triangle is isosceles. So this yellow thing is congruent to this yellow thing. Well, that yellow thing is in the triangle I care about. Yellow and the red tick mark and the right angle are all in each one of the triangles, and they represent, I believe it's side angle side. I have in one triangle, I have like in SQR, I have this side in SQR, I have the angle in SQR, and I have the yellow side in SQR, and that's side angle side. Would this be on the test? Not sure, because this seems like it's very semester 1 to me. So, would there be an explain? Yeah, but I think it'd be more like, when I name this thing, I think it'd be more having to do with similarity. Similarity was straight out of semester 2. Just like this. The altitude drawn to the base of any triangle does which of the following? Alright, any triangle. Now the problem is with this means any triangle. People are automatically thinking isosceles. Isosceles has some of these things true, but any triangle at all? Okay, here's one that'll get you. Altitude drawn to the base. Okay, here's, if I'm using this as my base, the altitude drawn to this base comes from here and it goes this direction. It goes perpendicular to that baseline, which is kind of like that. So here's the altitude, and here's the base. So let's see what it does. Bisects the base? No. Perpendicular to the base? Yeah, it has to. That's the definition of altitude. Bisects the vertex angle? Doesn't even, it's not even the interior of my vertex angle. And of course, not all of the above. If it's an isosceles triangle, then yeah, a lot of these things are going on, but the whole world is not isosceles triangles. Alright, I drew this on the Promethean board kind of sideways. It makes more sense, I guess, to draw it this way. If it's a closet, let's say it's 4 feet across, 3 feet deep, and 8 feet tall. What's the longest thing you can get in here if we go, say, from like this corner back here to the front corner up here? Like how long can that be? Well, this is like a double Pythagorean theorem question. That's kind of like it's the hypotenuse of this right triangle. It kind of goes that way. This segment down here across the floor would be a 5. This thing I already know is 8. So to find the blue thing, I just go 8 squared plus 5 squared. Sorry, I had to sneeze there. And I take the square root of that. So let's do that. The square root of 8 squared what? Don't make me mad. 8 squared plus 5 squared. And, oh yeah, that's the square root of 89. But if I want to know that decimal-wise, you have to make it tell you that. 9.43, which is closest to B. Okay, in the figure, DF is parallel to AB. Okay, that should warn you a little bit there. We have similar triangles now going on here. I know this is a right angle. BC, the whole thing is 5. This part's 4 and this part's 8. Alright, so this whole thing is 12. I have a right triangle here, a 5 and a 12. I just kind of want to already just go, you know what, that's a right triangle, this must be 13. Because of Pythagorean theorem. Oh yeah, and this is 3. So that tells me right away this is 10. I haven't really done any thinking yet. Alright, so I'm trying to find DF. This thing is completely just a part of the problem the whole time. It's just it's in my way. Forget about that. Oh, you know, I can do a better job of getting rid of it. If you could imagine this is sort of cheating. If you can imagine it just sort of being gone, this makes this problem a whole lot easier. It's kind of hard to erase on your test, I know, but yeah, just imagine that isn't there for a second. There's a point here that separates the 8 and the 4, but that just told me that was 12, so that's fine. Okay, I need to find this entire thing DF. Well, this entire thing is 12. It's in a similar triangle compared to that. Great. I can compare the 5. Oh, no, I can't. I need two things in one thing in both triangles that actually agrees. I've got a 12 is to x, sort of, and on this triangle I have a 5, and I don't know what that is, but here I have a 10 and a 13. So I can say 10 is to x as 13 is to 12, or I could say something like 10 is to 13 as x is to 12. Either way, I get 120 equals 13x. I want to take 120 divided by 13, and I know I need a decimal, so let's just do this. 120, oh, you don't get the key history on this. 9.23, blah, 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 so it's that. Alright. Portion of a regular polygon is shown. How many sides does it have? Well, if it's a regular polygon, all these little exterior angles are the same too. And what's nice about the exterior angles is they add up to 360. Each one of these has to be 18 degrees if this is a 180 degree angle here. I'm trying to show this way. And there's n of those, and they're all the same size. If I just take 360 divided by 18, I know how much is coming off at each corner. There must be 20 corners, and that's pretty easy. The other way to do this is the n minus 2. You could also do this as n minus 2 times 180 and divide that by n, and you know that's supposed to equal 162, and you can solve that for n, but wow, that takes a long time compared to 360 divided by 18. Alright, centers O, we're supposed to believe that it's on the diameter AC. The AC is the diameter. If AB is double as large as this, well, we can call this 2x and this x. The rule about the 57s in here is that the 57 has to be the average of, whoops, I said 57. 57 has to be the average of, or add up and divide by 2, the arc AB plus the arc CD. I said CD, now I wrote C. Great. So I know that 3x has to equal 114. Or in other words, x has to be 38. So if x is 38, the question is, what's the measure of arc B to C? Well, this is 38, because it was x. This is double x, it's 76. But from A over to C, that's 180, because that's a diameter here. So 180 minus 76, that's 104. Interesting problem. Okay, that's it for the multiple choice. I think I'm going to stop there, and then I'm going to go on to a new video. It's a good time to split it.